So in this way, mechanically you can, instead of thinking about the thing much, you can mechanically form the negation of a statement involving variable. So that was the last thing. So these are, do you see the thing? You just have to negate the first part and swap the quantifiers to form the negation. So these are elementary things about variables and quantifiers. So when you come across a statement like this now, where x is a real number, if someone asks you whether this statement is true or false, what should your answer be? Its truth or falsity depends on the value of x. It is true when x is equal to 1 and false otherwise. So there is no definite truth value to a statement involving variable that depends on the variable. But still it is true, because for every choice of the variable, you get a statement with constants and its truth or falsity can be unambiguously determined. Okay. So now, actually that is all about elementary mathematical logic. Now why I say elementary, it's because logic is a very vast subject. It has, in fact, set theory is also a part of logic, but there are many other issues in logic that are highly advanced, and it's so huge that you will be amazed to see what a book on mathematical logic can contain. This is one book by J. Donald Monk. It's called Mathematical Logic by Springer Verlag. And if you look at the contents, it has many things like recursive function theory, elements of logic, model theory, proof theory. Then logic is also not a single thing. I mean, there are many different, already I have mentioned modal logic, intuitionistic logic. So like that, quantum logic and many other different parts of logic are there. And study of logic involves also those parts where we deal with consistency of a formal system. Okay, for example, if you are given a formal system is a list of objects with some rules governing them, then just like mathematics, it's a formal system. Like that, you can have many different types of formal systems. So in them, what is the guarantee that you will never run into a contradiction or logical paradox? For example, a statement that is true but at the same time false. If that happens, then the system crumbles down. It is no longer useful as a formal system because it has run into inconsistencies. In fact, while studying set theory, naive set theory that we will deal with first, we will come across one such inconsistency called Russell's paradox. And from there we will see how axiomatic set theory gets around that inconsistency by forming some axiom called axiom of regularity. So those things will come. So what the point here is that logic is extremely vast. So what we have discussed here is the most elementary part of logic that we all need to make sense of mathematical statements. And this much is needed. This is the bare minimum that we need. And so In the coming videos, we will see naive or intuitive set theory. So you please try to go through the things and try to complete the things that I have not done here. I have asked you to do. So this is the end of this video. So this is me, your caretaker from a mathematical room. To support this channel, please subscribe, like, share and comment. Your feedback matters a lot, positive as well as negative. Otherwise, I won't know if what I'm doing is serving any purpose or not. So signing off for today. Have a nice day.